use utility of it, of course. So what are the directions for this? One, beyond trial laboratory demonstration. So we would like to move beyond laboratory demonstration where I do a search and get a few emails and display it. I would like to have a system where multiple users can access at the same time and search it, and when I click it, I see the results back immediately. It's not just a feeling of the feeling. There are a lot of building blocks behind the text structure. So you need a web interface and interactive response time, sub-second for millions of images. So you give a query, it should retrieve in sub-second, 0.0001 second you want to retrieve for million images. So you have to do lots and lots of offline processing and index them such that online retrieval is fast. You need algorithmic innovations in terms of fast nearest neighbor computation. Nearest neighbor computation is a challenging task, especially in large dimensions. If your number of features is high, nearest neighbor computation is costly, and you need a computationally efficient algorithm, and there are approximate algorithms to work. But the nearest neighbor won't do. You need to be efficiently indexing them and keeping in mind what users will ever look for. And third, you want to keep the user in the picture. You want to keep track of the user log, what user has been searching, and how do we store that information and how do we use it. So you need to build a system with lifelong learners. So the CBR system is a machine learning system which, when users use, it gets training examples, it gets supervision. And the supervision is used for improving or learning. And based on that, you can also give even personalized delivery. And if this person is typically interested in cricket matches, this person is typically interested in political news, this person is interested in, so this, you can have now delivery of results which are personalized. So these are all possible now in CBAR. So we built a system, FISH, fast image search on huge databases. So this was giving in thousands and millions of images in sub-second retrieval. Given a query image of this sort, it retrieves something like this. Okay, I'm not very happy about it. It's a few years back. Okay, so this is still not what we want to. So it retrieves, it meets the immediate requirement of a CBR of scalability. It allows multiple users to use a system, a backend, a search engine, a full-fledged search engine which works. But what we want more insight into the image. So when I search this image, if you look at this image, what is that I am searching in this? Just color. It's so naive. Nobody is actually going to search for this. I'd be interested in searching for example, only features of certain city, or only images of certain restaurants, or only images of certain objects. So my requirements are more involved than what can be actually captured with such naive descriptors which are available at this time. So our FISH system, so these are some other examples. Given a query image, it retrieves. Given a query image, it retrieves. Given a query image, it retrieves. Okay. Not bad, but not very good because this is still close to million images. Million is too small considering what you are going to see in the image analysis. So this is typically, for example, one of the popular database for testing CBAR systems is Coral database. And Coral database, you give this, you get only this. There are only few varieties available. You don't have natural, diverse images, and you are searching for very complex concepts in Coral situations. So this is why old CBR systems were showing good results, but when you put in practice, they were never done. So another thing what we did when we built the FISH is to do a long-term learning. So given this as a query image, what is important in this? There are pixels everywhere, but we know what is important. Given this, we know what is important. So since the users are using it for our sessions, users are doing relevant feedback within session and across session learning. Using both these, we do a long-term learning, that is, lifelong example of a lifelong learning system, which learns to say that in this image, these bright pixels are the content and dark pixels are the background. There is no image. I just give you an image and say, okay, what is important in this? What is salient region, salient region in this? There is no way of identifying. So the user feedback is effectively used to build to capture the visual content of this and say that okay, mapping back to pixels and say that look at this, in this image, these bright pixels are important, in this image, these bright pixels are important. So this gives us not only raw images, an understanding of the raw images in the sense of its importance. So now we would like to move to the next step, where we would like to move from images to videos. Okay. What's the most informative and popular video we all see? It's information rich, information packed. So we are talking about the search problem or information retrieval problem. So let us first start with something where the information is rich. News video has full of information. You have 24/7 channels. I don't know how many every dish connection has dozens of the channels. But are we getting the information what we are interested in? You have to sit in front of the computer for a long time to get some information. So user would typically like to build it. So our industry is now building a news video retrieval system. News video retrieval system is providing easy to digest videos for them. So I should be able to browse just the way I do internet. I should be able to just go and see the most important news. Highlights of the news. I would like to see when I want, not when they want. I should be able to search and show, okay, you show me this news appearing in every channel. So this is important news for me. I would like to see this news happening everywhere. I would like to see this news getting developed over days. There are no such functionality exists. But it is not very complex to do. Okay, it is not very complex to do. Why? I'll show you how to do that in a few slides. But, so what we did, we built a news video portal. We had two goals. One, we are not a commercial organization, we are not selling products, we are from a university. So we have always a research agenda in the mind. We would like to build a system which acts as a research platform. So we can actually test our algorithms for actual data, real data, and get a feel of it. We can understand what's the actual problem faced